What are the square roots of 3 minus 4i? We will do this formally, as well as how to select the right option within a short span of time. If we want to try it formally, let's assume the square root of 3 minus 4i as a complex number a plus ib, where a and b are real. Then when we square a plus ib, we must get 3 minus 4i. If we expand this holding square, a square plus 2a times ib plus ib holding square equals 3 minus 4i. A square plus I times 2ab. I square is minus 1, therefore it is minus b square is equal to 3 minus 4i. If we collect the reals and imaginary separately, a square minus b square is going to be the real component. The imaginary component is going to be I times 2ab equals 3 minus 4i. If we equate both real and imaginary parts, you'd get two equations. A square minus b square equals 3, as well as 2ab is equal to negative 4. Let's say it is equation 1, it is equation 2. From equation 2, if we make b the subject, b equals minus 2 over a. If we substitute this result in equation 1, a square minus b is minus 2a minus 2 over a. I'm just substituting for b. Then a square minus, if you square a negative quantity, the answer will be positive. Therefore, it will be 4 over a square is equal to 3. If you multiply throughout by a square, a to the power 4 minus 4 is equal to 3a square. Then a to the power 4 minus 3a square equals, a to the power 4 minus 3a square minus 4 is equal to 0. And it can be factorized as a square minus 4 into a square plus 1 equals 0. 4 is the square of 2. Then it becomes a square minus 2 square. The difference of two squares, it can be further decomposed into a minus 2 into a plus 2 into a square plus 1 equals 0. We have three factors. The third factor, a square plus 1, can never be equal to 0 because we know that a is a real number. Even though a plus ib is complex, a is real. Therefore, a square plus 1 can never be 0 because a square is always greater than equal to 0 if a is real. Then a square plus 1 always greater than equal to 1. So it can never be 0. Then either one of these factors have to be equal to 0. Therefore, a equals plus or minus 2. We already know b is equal to minus 2 over a. B is equal to minus 2 over a. For a, I am substituting plus or minus 2. Therefore, b is equal to minus or plus 2 over 2 is 1. The order is important. If I substitute plus 2, I will be getting minus 1 for b. If I substitute minus 2, I will be getting plus 1 for b. Then if I take the first pair, 2 minus ib, 2 minus ib is 1. If I take the second pair, minus 2 plus I. Then these are the square roots of the complex number 3 minus 4i. Option C. This is how you have to work for a structured question, but since it is a multiple choice question, we can go for some shortcut. 3 minus 4i, it is a complex number located in quadrant 4. Then the principal argument of this complex number is in between 0 to negative pi on 2 to 0. That is the principal argument of the complex number 3 minus 4i. Then when we take the square root, the arguments will be halved. Therefore, the argument of the square root of 3 minus 4i, this complex number, it is going to be this. We are going to get an inequality of this form. Then this inequality suggests that one of the square root lies in quadrant number 4. Similarly, if we add 360 for the argument of 3 minus 4i, it will not be the principal argument, but we will get the same complex number. Therefore, argument of 3 minus 4i considering this complex number located in quadrant number 4, the argument of this complex number can be in between 270 to 360. 270, that is 3 pi over 4. 360, that is 2 pi. Then if we take the square root, arguments will be halved. 3 pi over 8 pi. 3 pi over 8. In degrees, it is 135, I believe. And 135 to 180, it is in quadrant 2. Then one square root must lie in quadrant 2 and other one must lie in quadrant 4. If we check the option, this complex number lies in quadrant 1, so it is not possible. This complex number lies in quadrant number 4, quadrant number 3, it is not possible. Therefore, the option, we get a 50-50 elimination and we end up with A or C. Then if you just check one of the roots given in option E1 minus 2i, just square it. 1 plus 2 times 1 into minus 2i plus minus 2i square 1 minus 4i plus 4i square minus 1 minus 4 minus 4i. We end up with minus 3 minus 4i. But we need 3 minus 4i, so it can't be option A. Therefore,